Hello everyone, we're going to be talking about complex zeros. Factoring given an imaginary zero. So the example is the complex number z equals 1 minus 2i is a zero of f of x equals 4x to the fourth plus 17x squared plus 14x plus 65. Find the remaining zeros, because it already gives you one of the zeros, of f of x and write it in its linear factorization. We know that since 1 minus 2i is a zero, we also know that 1 plus 2i is also going to be a zero. So because that's the case, we can use synthetic division to help us simplify into linear factorization. So we write our coefficients for 0 because there's a missing term, 17, 14, 65. We bring down the 4 and we multiply. Now if you're not sure how to multiply that out, but 1 you distribute, so 4 times 1 and 4 minus 2i, that we end up putting that into our calculator. So if you go into your calculator and you press the mode, you want to make sure that it's not in real mode, but that it's in a plus bi mode. If it's already there, great. So the next thing is to go back to your original, and then we want 4 times 1 minus 2, and then the I button is actually found by pressing second period. And make sure you close parentheses, and it leaves you with 4 minus 8i. So that transfers to here, 4 minus 8i. Then we add 0 plus that gives us 4 minus 8i. But now I need to multiply again. So that's already in my calculator. So then I multiply by 1 minus 2 second period I, which leaves us with negative 12 minus 16i. So then that goes here, negative 12 minus 16i. I add those together and get 5 minus 16i. If you weren't sure how to add that, you can still use your calculator and put plus 17, which would have given you 5 minus 16i. And again, we want to take that and multiply it by 1 minus 2i, which is negative 27 minus 26i. So negative 27 minus 26i. We add that to 14, so plus 14 gives us an answer of negative 13 minus 26i. And again, we need to multiply, so times 1 minus 2i. And we get negative 65, as we should, because it tells us that it's a zero. So we know that that's one of our factors. But because it's imaginary, automatically we know that its complex conjugate, that's what the 1 plus 2i is a zero as well. So we went from a 4th degree polynomial and we depressed it now to a 3rd degree polynomial. We bring down our first term, we get 4. We multiply, we end up with 4 plus 8i. When I add, 4 plus 4 gives me 8. Negative 8i plus 8i is 0. Then I multiply, and I get 8 plus 16i. And then I add again, 5 and 8 is 13. Those are my real. My imaginary cancels. 13 times that is positive 13 plus 26i. And when I combine this, that gives me 0 and 0. That's also a factor, as it should be, because it tells us that this one's a factor, so we know that this one also has to be a factor. But now this brought it down to a 2nd degree polynomial. The 2nd degree polynomial, we're first going to write as such. When we write our zeros, we know that this is a zero. So it's always going to be x minus my first 0 times x minus my second 0. And then what I have left. In this case, it's 4x squared plus 8x plus 13. But the directions tell us that we want linear factorization and we want all of my zeros. Well, I know that this is a 0 and this is a 0 because both factors worked out, but I still have a quadratic, so I need to factor that even further. Well, this doesn't factor. You can't use bottoms up, you can't use guess and check. Nothing works to factor this, so I have to use quadratic formula. So x equals the opposite of b plus or minus the square root of b squared minus 4ac all over 2i, which simplifies to square root of negative 144, sorry, trying to do two things at once, divided by 8, which is negative 8 plus or minus 12i all over 8, which then simplifies, that and this need to simplify to be negative 3 plus or minus 2i, just kidding, negative 2 plus or minus 3i all over 8. So these are my two other zeros. If it asked for all my zeros, I have x equals negative 2 plus or minus 3i all over 8, and then I also have 1 plus or minus 2i. This counts for two of my zeros, this counts for two of my zeros, and I know that I should have 4 because this tells me so. My highest power is a 4th degree. But that doesn't help me with the linear factorization part. We factored these two so far, but I need to factor this further. Again, it follows the same idea. F of x is equal to, parentheses or brackets, 1 minus 2i. We have x minus 1 plus 2i. Then we have x minus, and then one of my zeros is going to be negative 2 plus 3i all over 2 times, and it really should be over here, but x minus negative 2 minus 3i all over 2. That should be one long line that it should just continue in terms of linear factorization. And I know that each of these are factors, that's what it has to break apart to. And then I know that it's linear because all of these x's have a power of 1. So this should be, sorry, this should be a 2